What's up, y'all? I'm Tom. This is Like a Math Class, and in this video we are going to talk about finding the inverse of a function. Let's get to it. Inverse functions are simply reversing the operations of a function. So what does that look like? Well, us math teachers, for whatever reason, we always like to draw function machines. I don't know why. Someone in a textbook one day made this idea of a function machine, and we've all latched onto it for all existence. I really don't know why we do this. But if we call this thing our function machine, here's our function. We're going to have some input that we put into this function, and then we're going to get some kind of output from this function. And this function might have a rule, and in this case our rule is going to be 3x minus 6. So when I put a value into this function, maybe I put the value 1 in. Then I'm going to take 3 times 1, that's 3 minus 6, and my output then is going to be negative 3. Now, if I've got an inverse function, what's going to happen is this inverse function is going to take that input. Again, let's draw another function machine. Why not? And what that's going to do is it's going to make the input be the output from the original function. So going into this thing is going to be negative 3. And then I need to have some kind of function, some kind of rule that is going to spit out a value of positive 1. Because if I originally put 1 into my function and I get negative 3 out, for my inverse function, I want my output to be 1 when my input is negative 3. So I'm reversing that, right? This was my output before, now it's my input. This was my input before, now it's my output. So what I need to do is I need to figure out what is the rule for this inverse function. This is the notation that we do for inverse function. And as I'm writing that, you should know that this is not a power or an exponent or anything like that. It is simply notation that says this is the inverse function. So when you're looking at this, when you see this, don't get confused and think that this negative 1 means that I'm taking it to the negative 1 power. That's not it. You got to look at the context. The context says f of x. We're using function notation. So if you see a function notation and that negative 1 in the middle there, that means inverse. So there's going to be some rule that goes in here that's going to make this thing happen. And that rule is actually x plus 6 divided by 3. Now you might say, well, wait, where did you get that x plus 6 divided by 3? We'll talk about how we do that when we get to our example here in a second. For right now, just trust me that this is the rule. And if we look at it, negative 3 plus 6, that's going to be a positive 3. Positive 3 divided by 3 does indeed give me a positive 1. So this would be our inverse function for this function over here. Now notice with all of this, I keep on saying the word function. And notice up here, I also say function. So in this case, the inverse, and not just in this case, but in all cases that we're looking at, the inverse must be a function as well. Well, how do we know if we've got an inverse function or not? Well, first we have to look at the original function, and then we can start looking at how might that translate into the inverse function. We had said way back when we first started talking about functions, that we can do a vertical line test to see if something is indeed a function. And in order to do that, we just take this vertical line and we just drag it across our function. And as long as we don't hit 2 spots at the exact same time, then we know that this is indeed a function. So this blue graph here is a function, and this green graph here is a function. But how do we know if the inverse is a function? Well, if you notice, I keep on saying we're reversing the functions, and I don't know if you picked up on this, but like when we had our inputs and outputs, we swapped our inputs and outputs. When we talk about functions, inputs are generally our x's, outputs are generally our y's. So we're swapping our x's and our y's. So in this case, if I'm doing the vertical line test on a graph for an original function, if I want to change that to see if the inverse will be a function, I need to do a horizontal line test. So I've got this horizontal line, and as I go down this blue function, I can see that I'm not hitting any 2 spots at the same time. Now down here it might look like we're running into a whole bunch of things at the same time, but this is just an asymptote. The x-axis is an asymptote here. But this one over here, bam, 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 we're running into two spots at the same time. So this green one over here, the inverse will not be a function. So what are these two different types of functions called? This one on the left, this is considered a one-to-one function. And this one over on the right is called a many-to-one function. And when we first introduced the idea of functions, we did talk about a one-to-one and a many-to-one. You can check out this video here where we do that if you're not familiar with these terms. A one-to-one function is going to pass both the vertical and horizontal line tests. And we also know for one-to-one functions, for every x, there is only one y. And for every y value, there is only one x value. All right, let's give ourselves a little bit of space here so I can fit this in on the many-to-one. And on the many-to-one functions, we already saw that it does not pass the horizontal line test. Many-to-one functions are not going to have an inverse function because there might be y's repeated for different x values. So if there's a y repeated for different x values, when we take the inverse of this, we're not going to get a function. That just means the inverse is not a function, even though the original is a function. So that's the key indicator of this many-to-one and the one-to-one functions. The one-to-one functions have an inverse function. The many-to-one functions, the inverse is not actually a function. It doesn't meet the qualifications to be considered a function. If this has been helpful so far, make sure you give me a thumbs up, like the video, and let's move on to our first example. So in this example, we've got our function g of x, and we want to find the inverse of g of x. Now, there's 3 quick steps that you can do to find the inverse of a function. First step is replace g of x or whatever function notation you're using for y. So we're just going to make this y equals 2x minus 4. And you could leave it as g of x or function notation, but it will get a little messy when we start doing the work for this. So that's why I suggest swapping it out to y. The second step is to switch the x and y variables. And then finally, the third step is to isolate y. And when you isolate y, you've then created the new inverse function. So for part A, we already did the first step. We changed it to y equals 2x minus 4. Now we're going to switch the x and y variables. So x equals 2y minus 4. And now we're going to isolate y. And so I'm going to take x plus 4 equals 2y, divide both sides by 2, and I get x plus 4 divided by 2. This is considered the inverse function of g of x. So I can write it like this. Now, it says graph x, g of x and the inverse of g of x on the same axes. I'm actually going to cheat. I'm going to go to step C first. Now, on any kind of homework problems, this is fine. If this were a test question, you can't really jump ahead to then go backwards. That's just going to kind of break the rules of the test. You generally can't use stuff down here to solve stuff up here in this middle step. But I think for our demonstration, I think showing the table of values first will help us graph it and then see the relationship between these two things. So part C, let's find some function. Let's find some values. So I'm going to start with x and g of x, and let's pick some values for this. So maybe I put 0 in for x. If I put 0 in, I'm going to get a value of negative 4. Maybe I put 1 into g of x. Then I'm going to have 2 times 1 minus 4. That's going to give me minus 2. Let's say I put a value of 3 into here. All right, so I'm going to have 2 times 3 is 6, minus 4 is 2. So we're going to have 3 and 2. You know, those are a couple good examples. Actually, let's do one more. Let's just, for kicks, put 2 in here as well, because 2 times 2 is 4, minus 4 is 0. And it's always nice to kind of see where our intercepts are. Now, what we saw before is when we find the inverse of a function. When we're looking at the inverse of a function, that means all of the outputs for our original function should be the inputs for our inverse. So I'm going to be looking at the values of -4, -2, 2, and 0. And when I put those into this equation over here, if I put -4 in here, -4 plus 4 is going to be 0. 0 divided by 2 is 0. Oh, look at that. These two things indeed swapped. If I put -2 in here, -2 plus 4 is +2. Divided by 2 is going to be 1. Oh, again, look at that. These two things changed. So all of this is going to continue to be the same thing. We're going to have 3 be an output here, and we're going to have 2 be an output there. You can check this on your own. Pause the video, pop those values in, and do some quick calculations yourself. Okay, so now we've got the inputs and outputs of our function in a table of values. Let's actually graph this thing. So let's start with our original function. I'm going to make this thing purple. So that means I've got to make this purple too. That way we can keep our color coding going, and it will make a little bit more sense when we look at it visually. So we're going to go for 0, -4. 0, -4 is going to be right there. 1, -2 is going to be right there. 3, 2 is going to be right there. And 2, 0 is going to be right there. So I've got this nice line right here. And now let's put in these values over here. So now we're going to put in -4, 0. We're going to put in -2, 1. We're going to put in 2 and 3. And we're going to put in 0 and 2. And we can see here again that we've got this nice line there for the inverse of g of x. And here is g of x. Now, I don't know if you can tell this or not, but what's actually happening is these two equations are indeed related, especially the graphs of them visually. And they are falling along this line that cuts right through the center there and cuts right down through this value, those lines right there. And that is the line y equals x. So what's actually happening with this graph is that we are reflecting across the line y equals x. And if we think about all the stuff that we've been doing, when we found the inverse equation, we've swapped the x and y values and we solved them. When we looked at the table of values, we swapped our inputs and outputs, or our domain and range, or our x and y values. So when we're looking at the graph, we're reflecting across that line y equals x. So it's all kind of related with what's happening. How are we changing these y equals x's, or how are we changing these y's and x's, and what's that ultimately doing for our inverses? So we've got a couple big ideas that we really want to take away from this when we look at all of these different inverses and the things that are happening here. Whether we're swapping the x and y's, whether we're reflecting across the line y equals x, or whether we're just changing our inputs and outputs. Like even if I saw a value here, I could change that input and output and get right up over here too. But the big ideas that I want you to take away from this: first, it has to pass both the vertical and the horizontal line test. Then you're going to switch your inputs and outputs, or in other words, you're going to switch the domain and range, or you're going to switch the x and y values, or the x and y variables, and solve. I say that solving, that's to create the equation. And what all of these things here are doing is they're creating an equation, or an inverse equation, that reflects across the line y equals x. And that's the big idea. Anything you're doing with inverse functions, if you can identify that it is going to be a function, then you're just swapping x and y, swapping inputs, outputs, swapping domains and ranges, reflecting across y equals x. That's it. And in the next video, we're going to look at how do we do this for rational functions. I'll see you there.